IMDb movie data set from 2006 to 2016. There is in the data set. It has objects, integer, and float data type. We have the statistical property of the data set. For first part, we'll do some pre-processing. In pre-processing, we will first handle the outliers. Use the outliers for revenue column. Use the outliers and for the rating column. Use the outliers for voters column. Now we move to missing value. Only two column, revenue and metascore has missing value. So we will handle this missing value using a linear regression model, which as we see the voter column and the voter and revenue has a moderately positive correlation. So with this voter to impute the data for revenue, to predict the data for revenue. The same method has been followed for the metascore. The metascore has a positive correlation with a rating, and it's a moderately positive correlation. And we do the same, and this is the genre. We split the genre by because the genre was separated by comma, so we split the genre by comma and count and the number of genres occurs in that genre column, where we can see drama has the highest number of time, and then action, comedy, and adventure and thriller. And musical, western, and war has the least number of occurrence. That means they are less popular genres than this one. And here's the actors. Here's the actors that commonly came to the actors column. Here's the actors' name who are commonly came in the actors column. It's a top 10 frequently came actors. It is a relational database. The first database is IMDB table. It holds all the information from the IMDB data. It's a clean data. Clean data, not the primary data. It's a clean one, which have zero null value, and most of the outliers are handled. And there's the movie table. This movie table has a primary key called movie ID, and it has nine columns. There's a movie genre table. It's a relational table. It has two foreign key, that is genre ID, which is came from the genre table, and the movie ID, which is came from the movie table. And the second table shows how many genres in a movies. That means the movie ID 240 has 6 genres, and movie ID 1000 has 3 genres. And the actors movie actors table, and this is also a relational database. It holds two foreign key. One is actor ID, which is came from the actors table. I made a mistake. It will be is actors, not genre. And there is the movie ID. It is came from the movie table. And there's the exploratory data analysis part. And this is the movie genre with highest rating. We can see war and animation, biography, and historic movie has higher average rating than other genre. And here's the movie genre with most average revenue. Animation uh, performs best in both rating and revenue category, as we can see category, in the rating category, and also in the revenue. And in terms of revenue, animation, adventure, sci-fi, family, and fantasy movie are top rated. Horror movie are worst in both case in terms of rating and revenue. Actors with highest average revenue genre movie. And these are the actors who are mostly involved with uh, rated movies. And here's the actors who have the highest average rating, who are involved in the highest average rating. And here's the histogram of rating. So you can see most of the ratings falls in between 6 and 8 range. Here's the histogram. It's a right-centered. It's an extremely right-centered, left-centered curve. And if we zoom the curve, you can see that most of the movie has a revenue between 0 to $60 million. There is a revenue correlation between revenue and rating. There is no correlation. There's a very weak correlation, as we can say. It's no correlation between uh, revenue and rating. That means the movie can earn a higher revenue and still have a bad rating. Top rated movies and director. Yeah, it's best director in the span of 2006 to 2016. Christopher Nolan is the best director. Revenue versus famous movie, and it's not necessary that if the movie is famous, it will have generate more revenue. And the voter versus Metascore, very weak correlation between these two. Voters, which there's a moderate correlation between voters and rating. We saw a spike in 2016 that the number of movies released in 2016 has jumped. The average vote is declining. If that voting trend is there's a negative trends in voting. That means the vote number of voters is declining every year. The average yearly rating there's a negative trend in the ratings. That means the rating is declining every year by 0.5% or 0.05. The average yearly revenue and the revenue of the average yearly revenue is also negative trend. The average yearly revenue is declining by 3.25 $3.21 million every year.